My name is Annah Bengasai, and I'm the Head of Teaching and Learning in the College of Law and Management Studies. One of the questions that I've been asking myself over the years is whether the work that we are doing in academic support is making any difference. Is it worth the effort that we are and the time that we are investing in it? As a result, most of the research that I've been doing recently has been focused on trying to answer some of these questions. In this presentation, I'm focusing on the foundation program, looking at its impact on graduation. I believe that an accurate estimation of what the foundation program is doing will help university administrators make efficient use of resources. And I think this is particularly important in the current situation where we have, a lot of scarcity. However, this is often a challenging task because of issues such as the quality of data, the availability of data. Which research approaches can we use to, infer causality, which lack of randomization, and then there are also issues of bias. Fortunately, there are a number of methods that we can use to make causal inferences. In this particular presentation, I'm going to focus on a propensity score weighting method, which are measuring treatment effects, as well as I'll also present results on a classification model. My outcome of interest is graduation, 5-year graduation status, whether a student has graduated within 5 years, and I'm using the foundation program as the treatment. So the student is either in a foundation program or not. My sample was constituted of about 2,552 students, of which 293 were foundation, and these were the 2014 and 2015 incoming cohorts. Some descriptive statistics. So in this slide, what I did was students who were excluded in the foundation here were not included in this analysis. I did not compare them with mainstream students because they did not get into mainstream. However, the results show that after excluding those students who did not perform well on the foundation program, the foundation students in mainstream are actually outperforming their accounting and BCom general counterparts in terms of first-year progression. However, a closer look at the data actually shows that the foundation students actually get caught up in the third year, meaning that there's something that we need to look into. I'm not going to go into that in this particular. In this slide, I present some, descriptive statistics on graduation rates, and the findings show that there really isn't much of a difference just by looking at the descriptive statistics in terms of the graduation rates for the foundation and the mainstream students. In terms of minimum graduation, there's a difference of about 1.1%, with mainstream students being more likely to graduate than foundation students. In terms of minimum plus one, there's less than 1% difference between the two groups, and in terms of minimum plus 2, there's about 2% difference between the two groups, with the foundation students being more likely to graduate in minimum plus 2 than their mainstream counterparts. While it's descriptive statistics, they give us an idea of what is happening with the students. However, they have a number of limitations. For instance, the relationship between the treatment and the outcome is not linear. There are other factors that influence whether a foundation student is likely to graduate in minimum time or minimum plus 1, or whether a mainstream vice versa. And we need to use methods that actually control for some of these covariates. In this study, I used a number of covariates that were available in the data from institutional intelligence. These include race and gender, admission point scores, school quintile, performance in the first year, academic support, financial aid, and campus residence. I classified these covariates using, the framework developed from Tindo's work, as well as Braxton et al., who have also revised Tindo's work. Okay, so we know that only a carefully designed randomized experiment can efficiently estimate causal effects. Therefore, in this method, I used propensity score weighting approach, which enables me to use observational data to mimic a hypothetical experiment. But before I get into this propensity score weighting approach, let me present some data from regression models. So from the regression models, the results show that in terms of minimum graduation, foundation students were 7% less likely to graduate in minimum time than mainstream students. In terms of minimum plus one, foundation students were 1% less likely to graduate than mainstream students, and these results were not statistically significant. In terms of minimum plus two, meaning graduation in minimum within 5 years. So this includes students who have graduated in 3, 4, and 5 years. In terms of minimum graduation, minimum plus two, foundation students were 5% more likely to graduate than their mainstream counterparts. And when I adjusted this for the different covariates in my previous slides, the results show that foundation students were 61% more likely to graduate in minimum plus two as opposed to their mainstream counterparts. In terms of propensity score weighting, the objective of this approach is to create a weighted sample in which the distribution, the covariates, the background covariates are the same between the treatment and the control groups. So in order to proceed with this approach, we first of all have to check whether the covariates are balanced. And I use the absolute standardized mean differences to check whether there is covariate balance. This graph actually shows the covariates that we use in this analysis. And before the propensity score weighting approach was implemented, it shows that there was much variability in the covariates. However, after adjusting, we find that the covariates, they were closer together. So in other words, the sample that was then used in the final analysis for the propensity score weighting approach was a sample of students whose background characteristics were more or less similar. This diagram as well just shows the differences before adjusting propensity score weighting adjustment and after propensity score weighting adjustment. Now, in terms of the treatment effects, in other words, we are looking here at whether the foundation program as the treatment had an effect on the outcome, which is graduation. And when we look at minimum graduation, as we can see, the coefficient is negative, suggesting that the foundation program had no effect on minimum graduation. However, when it comes to minimum plus one, we see that after adjusting for all the effects, looking at students whose background characteristics are more or less similar, the foundation program actually had a positive effect, about 3%. And then when you look at minimum plus two, the foundation program actually had a positive effect of about 7%. Okay, so in terms of the regression, now this slide just shows the regression results for the unadjusted model for minimum plus two, the regression adjusted for minimum plus two, and the propensity score weighting adjusted model. The results show that foundation students in all the three models were more likely to graduate in minimum plus two than their mainstream counterparts. However, these results also show us that there's an element of selection bias because the coefficients are different. It actually shows us that there's an element of some selection bias, which actually is induced by the different covariates that we used in this analysis. Now, the next step in my analysis was now to use a classification model to identify patterns or, the variables that best explain, student progression or graduation. So I used a classification tree approach to do that. And the classification tree approach, or called decision tree approach, is a supervised learning technique which classifies cases using rules inferred from existing data. So the algorithm works exactly in the same way, the human thinking works. It actually works in an intuitive way and uses if, then, else rule. So if this happens, then that happens, or else. And it's suited for classification problems with categorical variables. The tree is built in a hierarchical structure and using predefined variables, and it classifies the predefined variables, those covariates that we had on the other slides, into subgroups. So building the tree starts with a binary question. In this case, did the student graduate, yes or no? And then from this binary split, initial binary split, a recursive splitting is continued from the topmost node, which is the topmost decision node, which is all the values in the data set. And then it's continued, with a different variable being selected at each node, and each split being treated as a subpopulation until the cases can no longer be further split. And the practice in the field is to have 100 cases in the parent node, that is the main node, and 50 cases in the terminal node. I also used a KFold cross-validation technique where the data set was divided into 10 folds or 10 subsets of equal size. So each time, when the algorithm was running, 9 of those were being used as training data and 1 was being used as the test data. Now, in terms of, the classification for mainstream students, so which of these covariates that I had best explain graduation for mainstream students? From this slide, it actually shows that performance in the first year is the most important predictor of graduation for mainstream students. Students who are on good academic standing are most likely to graduate than those who are not in good academic standing, right? And then this is followed by rest. From those who are on good academic standing, we find that those who are non-African are more likely to graduate in minimum time than those who are African. And amongst those who are non-African, if they do get financial aid, those who get financial aid are more likely to graduate than those without financial aid. Now, in terms of minimum graduation plus 2, once again, we see that performance in the first year is the main or the most important variable which explains graduation, right? And among those students who are on good academic standing, their academic admission point scores, matric points, also are important. Those with higher matric points, 36 matric points and above, are more likely to graduate in minimum plus 2 than those without. And in terms of those who are at risk, gender also influences whether a student will graduate in minimum time plan or not. And amongst those with matric points of 36 and above, race is also another factor that influences graduation. And among those with matric points that are below 36, you find that whether or not they attend supplemental instruction, tutorials, or academic support, that also influences whether they are going to graduate in minimum time or not. Now, for the foundation students, graduation in minimum time, once again, is best explained by performance in the first year, followed by residence. So foundation students who are on good academic standing and are in campus residence are more likely to graduate in minimum time. And for minimum plus 2, once again, first year performance in the first year is important, as well as gender. Now, did the program make a difference? I would say the program make a difference. While there is, the effect on minimum graduation is negative, we know for sure that the effect of the program on minimum graduation plus 1 and minimum graduation plus 2 is positive. Will the program make a difference if more students were exposed to the foundation program? I would like to believe that there is potential for this program, even for students who are in mainstream. Now, in terms of rules that can be derived from this study, I'm just going to give an example of one node, which is node 3. These results show that foundation students who are not at risk and are in residence are most likely to graduate in minimum time.